So you might have heard like the ins and outs of tornadoes are not entirely understood. If you ever watched Twister, we're still trying to understand tornadoes. The problem with tornadoes is they happen so quickly. Another thing that's not entirely understood is lightning. You know, we know a lot, and I'm going to kind of teach you, or not teach you, but I'm going to kind of share with you what your textbook says. Notice that, or please make note that we don't know all that there is to know about lightning. But one of the things, and so when it comes test time for this unit of material, I have to kind of pick things that are hopefully obvious. And one of the things that we do know about lightning, we know a lot about lightning, or they do anyway, is that there are two types of lightning. One type of, and all lightning basically is a flow of electrons. We'll talk about that coming up, but so the flow of electrons can either be from cloud to cloud, and you can have cloud A over here, cloud B over here, and have electrons pass between them, and that's going to be lightning. Or you can have within the same cloud, you can have electrons flow, and that will be this cloud-to-cloud lightning within the same cloud. And actually, this is called sheet lightning, so it's kind of the lightning up there, right? 80% of all of lightning is this sheet lightning. And so sheet lightning's not going to hit you, right? There you go. The other type of lightning that's dangerous, and lightning can be very dangerous, so we need to respect lightning, is this cloud to ground lightning. So 20% is cloud to ground lightning. And what they both have in common is, I mentioned basically a flow of electrons. It sounds so tame, doesn't it? But so I'm going to kind of talk you through this flow of electrons. Now, in order for electrons to want to flow, there has to be a reason for them to flow. There has to be a region of positiveness and a region of negativeness. And can you kind of see within this cloud, there's kind of light blue pluses up there, positiveness, and red negatives down here, negativeness. Now, honestly, you have done kind of a, how do I say, have you ever taken a balloon and put it on your head like this, and you got static electricity going on? You have basically done what happens in a cloud. And I think I mentioned when I talked about the mature stage of a thunderstorm, the fact that we have an updraft and a downdraft, we get this going on, okay? And basically electrons are transferred, and I kind of added the word grapple down there at the bottom. And as it turns out, the grapple are heavier than ice crystals. These are two particles within your thunderstorm cloud, and the grapple tend to grab onto the electron. So basically you have a negative charge at the bottom of your cloud and a positive charge at the top of your cloud. So that's the beginning of a separation of charge to go ahead and get some electrons flowing. So what electrons are going to want to do is they're going to want to go from something negative to something positive. So let's focus on the 20%, the cloud to ground lightning. So I don't know if you can see it actually now that I'm looking closer, but even in this first slide when we talk about the formation of lightning, we've got down here, and it's really light, so I'm going to go ahead and we have a bunch of plus charges. Okay, this is the Earth, by the way. Down there it's kind of grassy. It's the Earth. One of the things that the Earth is great at is it's great at grounding. And it's a great source of electrons and a great place for electrons to go. And so kind of what it's doing in at the ground, in the vicinity of where the cloud is negative, is it's kind of, that negative part of the cloud is kind of inducing a positive charge down there at the Earth. Okay, so it's kind of ramping up to basically have relatively large difference, and then we can have electrons flow. That's what I'm kind of ramping up for there. And it kind of starts with this, which is associated with the updraft and downdraft within the cloud. Okay, so when the voltage difference is great enough between the base of the cloud and the Earth's surface, okay, then electrons are going to flow. And so this is like, I've read that if you are out and the weather's kind of iffy, maybe you're going to have some electrical activity, thunderstorms and lightning, and your hair starts to kind of tingle, okay, that means that actually you might be you may have a region of positiveness being kind of induced on you, and your hair is starting to kind of respond to that. One thing about it, I mentioned lightning. Lightning is very dangerous. Lightning can be very deadly. Lightning can reach way in advance of the storm. I mean, it doesn't always, but it can. So here we have some terms here. We have kind of the initial flow of electrons through a path called the leader. We have kind of tentacle sort of things called step leaders. This runaway breakdown is really kind of, once we start to kind of open the spigot and electrons start to begin to flow, we have a lot of electrons flowing. Now, if you've ever plugged something into the wall and you kind of take the power cord and you feel it and it gets like a little bit warm, okay, electrons are flowing, and depending upon the rate at which they flow and kind of the resistivity of the material they're flowing through, it can create some heat. And so that's what we have here. Actually, the heat ultimately created by the flow of electrons in a lightning bolt is hotter than the surface of the sun. Not hotter than the interior of the sun, but hotter than the surface of the sun. So I have some more terms here. And actually, if you look into one of the things they know about lightning is that path, that flow of electrons, it's kind of revisited a few times. So you have the initial flow, and then you have a flow back up, and you can have a flow back down, okay? And so we have these multiple strokes, and actually you can kind of see in this lightning bolt, actually the fact that there's multiple lines there, okay? So we say that the overall lightning flash is really a series of lightning strokes. And so here, this is kind of talking about the series of lightning strokes. What happens actually is it's kind of a back and forth sort of process. And like I said, electrons kind of flow down, and they flow up, and they flow down. Okay. And actually, it's this return stroke, I think that's right, it says even more powerful flow of electrons from the cloud to the ground. Some more terms here. Okay, and actually, to be honest, these all get a little bit confusing to me. We have dart leaders in the vicinity of the original path that electrons flowed. So I probably won't get too nitty-picky down. I won't probably get too picky when it comes to your unit exam and I ask you some questions about lightning, but I hope you kind of have some ideas.